Okay, I'm actually really excited about today. I feel like some things are going to come together. Let me be perfectly honest with you. If you understand the last video, the part 1 of this, you don't technically need this video, but I feel like this will be a good sum up of everything we've learned. And this is actually the last new material for this unit. So let's go ahead and review. In another video, I talked about 5 steps for solving multi-step equations. I want to review those here, and I'm going to write them in red off to the side. The first thing we like to do to make life easier for ourselves is get rid of all the parentheses by distributing. You don't have to do this first, especially if there's only one set of parentheses, but it does make it easier by making it so there's no fractions. The second thing we do is combine like terms. I called it CLT, like your favorite sandwich. It's now with chicken instead of bacon though, which is sad because I love bacon. The third thing you do is get rid of the extra variable term. And a lot of people struggle with this one, but you always do that by adding or subtracting. And then 4th and 5th are both undos. 4th, you undo addition and subtraction. So this is us doing our PEMDAS backwards, undo multiplication and division. So this is now SAD MEP. If there were exponents and additional parentheses that you hadn't gotten rid of with distribution, then you'd have that right here, but we don't have any problems like that yet. Okay, so we're going to follow those 5 steps and we're going to solve these, and if they have no solution, we'll write that down. If they have infinitely many, we'll write that down. So on number A, distribute, I don't have to do because there's no parentheses. So I'm going to move on to combine like terms. I see 2x and 2x here, so I'm going to combine them and get 4x because 2 plus 2 equals 4. And then you might notice that these look very similar, so you might have a guess as to where this is going, but I'm going to follow my steps here and undo the extra variable term by subtracting 4x from both sides. And that's fun, they cancel. So when they all cancel out, we know this is going to be a special case. I end up with 2 equals 2. And when does 2 equal 2? Always. So I'm going to say that this has, it's not no solution because 2 always equals 2. So I'm going to write infinitely many solutions. And remember, you can abbreviate infinitely many solutions, but I should be able to read it like infinitely many solutions. Just writing infinity doesn't actually work. That's not true. Okay, so now we're going to go ahead and do the next one. Here's our first special case. And B, I don't actually know if it's a special case or not. Let's see. I'm going to go ahead and solve. Let's go through and do my steps. First, I distribute. So I'll do that one first. And I get on this side negative 2x minus 2 equals negative 2x plus 5. And then I combine like terms. I don't see any on either side. If I look over here, no like terms. If I look over here, no like terms. So I'm just going to skip that one and move on with my life and get rid of the extra variable term. So I'm going to pick one. They're both the same, so I'll do the opposite by adding 2x to both sides. And I get negative 2 on this side and then positive 5 on this side. Now, when does negative 2 equal 5? Never! So for this one, there is no solution. Okay, we actually haven't had to do all our steps yet. We've only gotten to 3 for each of these because they're special cases. That's the nice thing about special cases, is that it actually is less math that you have to do, so I kind of like that. Okay, let's do C. Oh, I need to see my steps. Hang on. Okay, so first thing I'm going to do is distribute 3 times x and 3 times negative 1. So I get 3x, and 3 times negative 1 is negative 3, and then the other side stays the same. Cool, did the first step. Then I'm going to combine like terms. I don't see any on this side, and I don't see any on the other side because the x, there's nothing to go with it, and the constant terms, there's just 1 on each side. So I don't have to do that step. Moving on, get rid of the extra variable term. So this one has different ones, so I'm going to pick the one that when I subtract, it will no longer be negative. So subtract 2x from both sides. And I get 9 on this side and 1x, or you could just write x, minus 3 on the other. So I got rid of the extra variable. Now I actually do have to undo addition and subtraction and multiplication and division. So I'm going to undo subtraction by adding on both sides. And 1x equals 12, which is actually fine. You don't have to undo 1, so x equals 12. And this one is one solution. Okay, so previously we talked about how if you get the end and x equals a number, it's one solution. If you get two different numbers, then it's no solution. And if you get the same number, it's infinitely many solutions. There's actually, I can tell before we get to the very end whether or not it's going to be no solution or infinitely many. So let's summarize what we've learned. I'm going to change my pencil color to purple. And this is basically me summarizing if I had a little bit of a less simplified equation. So this first one, when we simplified it up to this step, the very first step, we got 4x plus 2 equals 4x plus 2. So what we notice about this one is that it looks exactly the same on both sides. Basically, anytime it's exactly the same on both sides, it's going to be infinitely many solutions. And you can also say, once you get to an x term and a variable term, you have the same coefficients, and you have the same constants. So we're going to write that down. Guys, I don't know what color to use. We'll keep it as blue. So if it's the same coefficient and the same constant, then there's infinitely many solutions. Okay, so the next one was no solution. At that very topmost step, we had the same coefficient. Let me actually write this out. Okay, we had the same coefficient, but different constants. And that actually works all of the time. Sorry, I apparently forgot how to spell. So the reason why this will have no solution is that if they have the same coefficient, those coefficients, basically you get rid of both of them. You subtract them both out. And then whatever you're left with, if it's different, it's no longer equal. So it will always have no solution if you get to that point where you have just the coefficients and constants, one term of each type, and you look at those and they're different. Now, some people use this method and they get a little confused because they forget which terms are which. So you can't compare your x term on one side with your constant term on the other. And then for one solution, I'm just going to use the words I already wrote. If you look at this equation, the coefficients are different. So you can just look and say, oh, those are different coefficients. And then I'm always a little sad because I have to do actual math. I have to find out what the actual number is. So one solution is different coefficients. So you might want to write that down, keep it in mind as you're doing your homework, and then you can actually do it in fewer steps. You can just solve to where each side is simplified and then be able to tell one solution, no solution, or infinitely many solutions.